Hey, year 10. So this is about 9e, which is standard deviation. Now, standard deviation, as I've written up here, is a measure of how spread out the data is from the mean or the average. But before we really go over that, I just want to focus on kind of what we have been working on. So this sort of stuff here. So hopefully you can see I've drawn a couple of box plots, and these are called parallel box plots because they're like on top of each other here. And I've done that so I can sort of compare them. So we've got our scale down here and then our box plots up there. I've popped the numbers, the key numbers in there just to make it a little bit easier. You might not always see that. But what you'll see with these two here is that their median is at 10. So they both have the same median, but can you see that they're spread out differently? So this one here, it's not really as spread out as this one here is. Okay, so there's a bigger range in the data. Now we've looked at things like the interquartile range and the range, which tell us how spread out everything is. So if you look at these two box plots here, we can already see that one's more spread than the other one. So this one here, this has a range of 9, where this one here, which is more spread out, has a range of 14. So that number 14 shows that it's more spread out than this one. And we can compare the IQR as well. So the IQR of this one is more spread out than that one. And we can see it visually too. So we are slightly or sort of familiar with like measuring the spread of data through these two measures here, but standard deviation is just another way to do it. Okay, so the larger the standard deviation is, the more spread out the data is. Okay, so let's actually have a look at the formula that we've got here to work out what the standard deviation is. Now, when I was talking about range and interquartile range before, they don't really have anything to do with the average, whereas the standard deviation, it's telling you how spread out from the average it is, or how spread out from the mean it is, because average and mean are the same thing. Now, let's have a look at this formula that we can use to find the standard deviation. Now, it looks pretty complicated, doesn't it? So we've got this x1, x2, xn, and then we've got the x bar here as well. Now I just want to talk about what each of these things actually mean. So all these x's, so x1, x2, x3, x4, all the way up to whatever, they're just the different numbers that you've got in your data set. So my x1 for this data set down here, which we'll use soon, is going to be 1, my x2 is going to be 2, my x3 is 3, my x4 is 4, x4 is 3, my x5 is 5, etc. Okay, so it's just all the numbers that you've got in your set. Now, the X bar here, and I've got it written over here, that just means your mean or your average, which is something that we should know how to work out, but I'm going to do it for you anyway. And then N, which you can see down the bottom, is just however many numbers or terms you have in your data set. So with this data set here, we've got 1, 2, 3, 4, 5, 6, 7, 8 terms. So N would be 8. Okay. All right, so let's actually use this formula here to work out the standard deviation of this data set. All right, but we're going to need the mean first because that's what it asks in the question. So calculate the mean and the standard deviation. Let's forget about the standard deviation for now. We'll just do the mean. So to work out the average, we just add all these up and divide it by the amount that we have. So, oops, should be up the bottom, up the top, not down the bottom. Don't know what I'm doing. All right, so if I add all these ones up, I can write it all down, but I might just do it in my head. 3, 6, 9, 14, 20, 40. So they all add to 40. And then there were 8 terms. So 40 divided by 8. So that means our average or our mean is going to be 5. Cool. So we've answered the first set, or the first part of the question, what the mean is. Now we need to do the standard deviation. So we're going to be using this formula here. So my standard deviation equals, move up so you can see it, standard deviation equals, all right, now I'm just going to focus on what's going on here first. Okay, so this is saying the first term, take away the mean and then square it. So that's 1, take away the mean, which we worked out to be 5, and then square it. So I need to do that for every term. So the next term is 2, take away the mean, square it. Third term, 3, take away the mean and square it. The next term, see how I'm just doing it for every single term? So I've done it for the first 4, Now I'll just do the other ones as well. Okay, so I've done that line. We need to divide that by n minus 1. So n is the number of terms we had. It was 8. So 8 minus 1. And let's not forget to square root the entire thing. So there's a fair bit under that square root, isn't there? So you can use your calculator to do this, because often the numbers are going to turn out a little bit yucky. So I did that in my calculator before, and the answer that I got was 3.51 if I ran it to decimal places. So for this data set here, we have a mean of 5, which is a measure of center, and then we have a standard deviation of 3.51, which shows us how spread out the data is. So if we found out that the standard deviation was 4, that would mean it would be more spread out than this that we've got here. Or if we found an answer that said the standard deviation was 2, that would mean that it's less spread out. So all the numbers are closer together. Okay. Hopefully that helps. I'll get you to have a go at the questions that are written for you in your work schedule.